Have you ever wondered what benefits you get from being an Inel student? Your learning will not only remain in theory, you will also learn through practical cases, software, projects, and more. You will share experiences and knowledge with students from various countries and receive continuous advice from high-level instructors. In addition, you will have access to the virtual platform where you will find resources and complementary material, so you can be able to relive the classes whenever you want. Don't forget that our certifications are internationally recognized. Get to know us a little more through our networks. With Inel, your education has no borders. Have you ever wondered what benefits you get from being an Inel student? Your learning will not only remain in theory, you will also learn through practical cases, software, projects, and more. You will share experiences and knowledge with students from various countries and receive continuous advice from high-level instructors. In addition, you will have access to the virtual platform where you will find resources and complementary material, so you can be able to relive the classes whenever you want. Don't forget that our certifications are internationally recognized. Get to know us a little more through our networks. With Inel, your education has no borders. Have you ever wondered what benefits you get from being an Inel student? Your learning will not only remain in theory, you will also learn through practical cases, software, projects, and more. You will share experiences and knowledge with students from various countries and receive continuous advice from high-level instructors. In addition, you will have access to the virtual platform where you will find resources and complementary material, so you can be able to relive the classes whenever you want. Don't forget that our certifications are internationally recognized. Get to know us a little more through our networks. With Inel, your education has no borders.
Good morning, dear participants. Welcome to Inel and our new cycle of Masterclass. Who is greeting you is Fabricio Cárdenas, your tutor. Today we are going to talk about real application case of power transformer protection in PowerFactory. This is the link of your consultations. During the presentation of our instructor, you will have access to this. There you can make your questions according to the topic presented. This is our commercial executive, Lisbeth Ore, who will give us very valuable information at the end of the masterclass and will announce a big surprise for the participants. You have her contacts here in the slide, if you have any doubt. I present you our new instructor, the PhD Ahmed Othman, who is an specialist in power system protection. He is an electrical engineering by Saksag University, Egypt, with PhD degree in electrical engineering by Aalto University, Finland. A specialist with more than 20 years of work experience in electrical engineering and electrical power system operation. Currently, instructor of Inel Escuela Técnica and senior electrical lead of SunGrid Solution Incorporation, SGS, Toronto, Ontario. He has experience in protection of power system, advanced experience in power system studies, distribution, system operation, and planning, design of AC and DC power distribution systems, and MV/HV voltage power transmission. Good morning, Mr. Ahmed. We are ready for your presentation.
Good morning, everybody, or hello, everybody, based on your place and location. It's good. Hope it is good time here and the chance to meet and introduce such session with you. First of all, let me share my screen, and after welcoming everybody. Do you see my screen? Let me know if you are seeing my screen well.
Yes, we can see your screen, Mr. Ahmed.
Okay, that's great. So let's start and go ahead for our session or class today. About some practice and skills about how to protect and how to model power transformer on PowerFactory, Dex Island. It was a quick introduction, and let me make it quick here again. That's me here, Ahmed Abdel Maqsood, or Ahmed Osman. My full name, Ahmed Muhammad Osman Abdel Maqsood. I am a specialist in power system study. I got my PhD from Aalto. A previous introduction. I have been working in multiple places like Europe, North America, and the Middle East. So it's like a bunch of items through my profile. So my master and bachelor from Egypt, my PhD from Finland. My experience was in North America beside both countries. Let me move ahead for the master class content. Content for today will be like, I always prefer to make some notes here. Let me go back, sorry. Let me try to get like a pointer here, like pin pointer. So we are focusing on transformer differential protection. So that is our concept, which we need to tell about by today. We have some content like agenda for our class. So we need to get a concept and the principle about differential protection, how differential relay can be implemented on a transformer, how relay is operating and work on a transformer, what are the factors which impacting and affecting the differential protection, what are the challenges, then we are moving to challenging and problems we may face in transformer differential protection, what are the standards we need to know about to handle those protection schemes on transformer or differential or generally speaking. Then we are moving for practical differential protection on the market, on the practical market and industrial market. What are the knowledge we need to get about to be familiar with the practical differential protection? And at the end, we need to practice or tell about some practice and some simulation skills on big silent or PowerFactory. Those are the items which should be included on our agenda by today. So for today's class, there is some keywords or some key title, I would say. So our presentation or our session will be categorized and break down those keywords and the key title. First, we need to get some overview about transformer. Then what are the protection aspect on transformer? That's another keyword, which we will focus on differential protection. Last keyword or last key title would be dig silent. So we will find our presentation like divided on those three main topics. Transformer, first we learn about transformer, then we learn about differential protection. Lastly, we know about dig silent as platform or software to handle those topic transformer and the protection. So general concept, we need to focus on transformer differential protection. So first of all, let's have a quick overview about transformer. What is the transformer? I know it's maybe well known, but to apply any protection aspect or scheme, we should be aware and familiar and digest all principle and modeling and operation about the device or the equipment we are applying our protection on. So let's start with transformer. What is the transformer? What's the construction? How we can model transformer? What's the principle of operation of the transformer? That's the first key. Again, that is the first key word or key title of our today class. So what are the transformer? At the end, we are familiar. I suppose that we have certain idea at a certain level that transformer are the electrical devices. So at the end, we are targeting electric devices which are used to convert the voltage level from up to down. So either we are stepping up or stepping down the voltage level. So we are targeting stepping up. So our transformer at the end, either it is step up if we are rising the voltage level from certain level to higher, or we are targeting stepping down if we are targeting to reduce the voltage level from certain level to down. So that is the main description about what are the transformer. At the end, the transformer as a device, it is only working on EC levels. There is nothing called DC transformer. It is EC device, and it is mainly depend on electromagnetic induction phenomena, which we would tell in next slides. So transformer, again, just to make it brief, it is a device which is used to transfer power, to keeping the power, but in different EC voltage level, either up or down, and that is a transformer. What are the parts or the construction of any transformer? At the end, the transformer, either it is primary winding or primary coil, or secondary winding, secondary coil, and there is iron core. So there is iron core, and we have primary winding, and we have secondary winding, and based on the ratio on two sides, we stepping up or down as it would be clear here. We have iron core, primary coil, secondary coil, which most likely they are covered ones. So that is the main shape of the transformer. Again, in such section or in such portion of our presentation, we are focusing to digest the transformer before applying the protection, which is differential. Because while we are focusing on differential protection, we will need to have those terminology and those foundation about transformer. So our transformer primary winding, secondary winding, and IR core. Again, the same concept that the structure of transformer in 3D diagram, like 3D. So we have like a main core, iron core of the transformer, some winding and the parameter, which is now here in touch slide on left. They are the primary winding. So we have primary winding, we have primary current, we have primary voltage, and sure, we have primary turns ratio. On other side, we have secondary winding, we have secondary current, secondary voltage, and also secondary turns ratio. Based on the ratio of primary to secondary, we will have stepping up or down, especially we creating some magnetic flux, which is flowing on the core itself, and there is some cut on those lines of magnetic flux to generate voltage on other. How the transformer working? The transformer working, we are generating and make the current of the primary flow through the primary winding, and we have Fleming rule. So if any current, AC current, is going through a coil, there will be magnetic flux generated and will be rotating through the core. And on the other side, there is some turns which cutting those lines. Due to cutting of those lines, there will be secondary voltage. That is the principle of the transformer. Most likely, such code should be eliminated for a certain reason, at least to avoid an eddy current and reducing any losses in the core itself. So the principle, again, the principle of the transformer depends on the mutual induction. So we have a certain primary sources creating magnetic flux. Such a magnetic flux is cutting by secondary turns ratio or secondary turns coil. And from there, we can generate a voltage depend on how much cut on those flux lines. And that's such principle of operation is mainly depend on the mutual induction. From there, we can jump to the transformer operation, which depend on principal mutual inductance. The same concept about the primary side and some flux cutoff. And from there, we can generate an induced voltage from AC source on primary to secondary side, and usually secondary side is connected to the load. So usually primary is connected to the source and secondary connected to a load. And here, based on the turns ratio in primary to in secondary, we can stepping up based on the ratio VB or VS or IS, secondary current to primary current. So the transformer is used for transmitting power. It keep to, we applying transformer to reduce some transmission. At the end, if we have a power grid, such grid have source and has load at the end. We have generation center and we have load center. To be able to transmit the power for long distance, we should use transformer to stepping up voltage, reducing current, transmitting power, and at the end, we can stepping back such voltage level to be suitable for the load. So we are using transformer for transmitter power, reducing cost, adjusting the voltage level, and create some isolation at the end. Those primary and secondary isolated electrically, but connected on magnetic wise. So it's another application of using transformer, which is creating electric isolation. We can use it for filter and so on. Based on equation, we are applying such N1 and N2 primary and secondary, applying EMF at primary over EMF as secondary equal to N1 over N2. So the voltage will depend on the turns ratio at the end. With keeping at the end, we have bunch of power. We have active power, reactive power, and total power. We will keep the volt ampere power for both sides at the same level. So S primary, which complex power, would equal to S secondary. So volt ampere power at primary equal to the same one. Let me check. I believe there is something on the chat. Yes, it's just some tips about the session today. So the same concept, how to make it equivalent EMF and the current and impedance for both sides based on the turns ratio. So if the current is proportional, the voltage is proportional of the turns ratio, the current is proportional to inverse proportional to the turns ratio. Impedance of both sides is proportional by square of the turns ratio. That's the ideal transformer. And how to describe the rated value? We have rated value apparent power. We have rated value primary voltage. We have rated value of secondary voltage. How to describe any transformer based on the winding and based on the core, where the core have some eddy current and the hysteresis losses. So such equivalent circuit. Here, the equivalent circuit of the transformer. And when we will apply the differential protection, we will differentiate between both current. Here we have current as the primary, and we have current as secondary, and we should keep no differential between the turns and the ratio between them. Based on EMF equal N1 over N2. There is different shape of the transformer. We have some of them based on the core and based on the connection. So we have some of them called shell and some of them called core type. So we have core type, where the winding are settled on core. On other side, we have some other which called shell type, where there is like a mid leg where the winding are replaced and settled on them. Those are the two shape. We have a cut view of the transformer, where is the primary, secondary, and where is the high voltage bushing and low voltage bushing. And sometimes we are using some oil tank to make some cooling system for the transformer. So by such section, we are getting some idea and digesting the transformer. Let's jump now for second keyword or second title, which is transformer protection about the differential. At the end, the differential protection is a level of protection which can allow a second backup over the overcurrent. At the end, we have a certain protection over current, and we have some other protection on the transformer, which can name earth fault. But due to the nature of the transformer, which we have primary current and we have secondary current, and we have proportional ratio between both of them, we need a higher level of protection, which maybe overcurrent is not suitable for, and such level of protection is differential protection. So differential protection would be like a second layer over current and earth voltage. And at the end, there is a certain fundamental. If we have a node at the end, if we have a node here, we have some current in, so we have summation IN, which is summation of all branches current, and we have summation I out. And from Kirchhoff current law, summation of IN equals summation of I out, and it can be described like summation IN minus summation I out equals 0. So there is no differential. There is no difference, we can say. So based on such small principle that summation IN minus summation I out has no difference, equals 0. If the system balance, what's the difference should be 0. But if there is a difference between I in and I out, so the protection device should sense and act. Which protection device should act at such a moment would be the differential protection concept. The differential protection concept has a responsibility here, or the major element to act. So if we have a certain device and we have normal paths based on the summation in, the normal operation will lead summation equals 0, and abnormal operation will lead there is certain value for such a summation. So that is exactly the principle of the differential protection. We will add a bunch of current transformer. We will have some current transformer. Those current transformers should sense the current, so should measure the current, and from those measures for the current transformer, we can calculate using the relay. So the relay will accept all signal from current transformer. So all current transformer will supply signals to the relay. Such relay will confirm the processing that our summation of in minus summation or I out or summation the current equals 0, so we are normal, or there is a difference, so we should act. And that is exactly how differential relay would be implemented on transformer. If we need to implement on transformer, we have primary current transformer and we have secondary current transformer. At the end, we have such I primary and we have such I secondary, and the summation of such a processing which go through the relay here, differential relay, should be equal 0 at normal operation, and if there is abnormal operation, and abnormal operation may equal to there's a fault. So if there is internal fault here, and we will see in next slide, if there is internal fault, so such a differential value will exist, and from here the relay will sense and will act because he will find a difference or differential current, and which mean volt, which mean please try to trip or act. Let me ask, before proceeding, let me ask the participant and our delegates here, do you have any question or any rising discussion before proceeding up? Anyone, if anyone need to ask before proceeding, or if there is some rising concerns or questions or discussion required, please let me know.
Actually, Mr. Ahmed, the consultations will be by the QR,
Absolutely.
so
Absolutely.
Yes.
Absolutely, absolutely. That's okay. I like our session to be interactive at a certain level, but it's okay for now to collect those questions by consultation.
Yes.
So let us proceed at least to confirm how our differential relay on transformer will operate. Again, it's the same concept. So we have a transformer. We're using current transformer at primary side to sense the current at side 1. And we have current transformer at secondary using current transformer and to sense the current on the other side, secondary side. And based on those IR, which is differentiating between IS1 and IS2 at certain node, if there is a balance normal, IR will equal 0, and such a moment everything is good. If there is internal fault, internally on the protection zone or protected zone, at the end, the zone between CT1 and CT2 is a protected zone. Such a protected zone, if there is internal fault in between, so there is no balance between IS1 and IS2, there is a value for IR, so the relay will start to act because the difference current or differential current is existing. That is case number 1. Based on those formula, at the end we have certain formula which confirm how we can relate between current at primary side current at secondary side at a fault moment, especially if there is a turns ratio which confirm there is a proportional ratio between secondary and the primary side, as we was referring to the transformer explanation. While we are explaining more and digging more for the details of the transformer, we found such proportional based on the turns ratio between secondary and the primary. But in case there's a fault, the differential current would exist, and there is a tripping action can be created by the relay or differential relay. And here also we confirm that if there is a current flowing here, if there is a certain current are flowing through the relay, and such current is existing at a certain level, so the relay will give a tripping order to the circuit breaker, and the circuit breaker operation initiated instantaneously. And in such case, we are protecting our transformer. So we are protecting our transformer. On other side, if there is external fault, and the expression of external fault is depending on such protected area. Again, where is our protected area? The protected area is the area between CT1 and CT2. For any differential relay, we are protecting a certain zone which are in between CT1 and CT2. This is the protected area. Any fault internally is inside the protected area, and any fault outside is like external fault and outside of scope of differential relay. So what will happen in case we have external fault? If we have external fault, so the relay will see like a normal, because the ratio between IS1 and IS2 here, we have IST1 and IS2, primary, secondary, both sides. We will act like a normal because it's external fault, where the fault is out of scope of the protected zone. So the relay will have I differential 0, so there is no action. So it is like here he confirmed the differential relay is ensuring the correct fault discrimination. The differential relay is doing a discrimination between internal fault within the protected zone or external fault which is outside any external or outside the protected zone. That is how the differential protection will operate and work during it is implemented on a transformer to protect a certain protected zone. So now we get an idea about the transformer as a device. We get an idea about the protection of transformer, especially differential protection on a transformer, and what are the principles, how it would work. Then let's move ahead. What are the problems or challenges which we may face while the transformer differential protection is in operation? First of all, we should highlight, during we are confirming the operation of the protection or differential protection, we are stressing on it totally depends on CT. We will measure the current using current transformer, either on primary side or secondary side. So the current transformer accuracy, current transformer saturation, and also in rush current which is happening on the transformer itself, and the excitation, over excitation of the transformer itself, those are the phenomena which or those are the problem or challenges we may face while we are protecting a transformer. And rush current of the transformer, excitation of transformer, accuracy of current transformer, saturation of the core of current transformer. At the end, each current transformer has a certain core, and such core is subject to saturation curve. We have a saturation curve based on the phi to I electromagnetic characteristic or behavior. We have a certain saturation we may face. Those problems are mainly producing fault trips. Fault trips. What are the fault trip? A fault trip, which means maybe there is no fault, but the relay is tripping. That's a fault. Or maybe there's a fault, but the relay is not tripping. So we have like faulty trips, either on or off, either there is fault or not. So there is mal operation or false operation for the relay of differential. And from here, we should confirm how to implement differential relay. To implement a differential relay on a certain protected zone or on a transformer, there is a certain item and component we should confirm. It is there. Current sensor or current transformer. We have data acquisition system to collect and processes, collect the currents and process and to compare. We have filter, we have processor, we have estimator, and we have at the end decision maker, which is classifying the data and send a signal based there is fault or no fault. So at the end, such relay is feeding circuit breaker to tell the circuit breaker there is fault, please trip, or there is no fault, please continue. There is no fault. So those are the implementation map or structure of any differential relay. So let's count and let's make a zoom and focus on one of our problem, which we tell about, and maybe in one of our previous slides about CD saturation problem. How the CD saturation problem would affect our differential. So at the end, each CT has like a certain core, and it is applying a certain electromechanical amount based on the current. If such CT is working on the saturation, working on saturation region, so the CT would create some unbalanced signal and the current, which is violating the operation of differential protection. And that's why we should detect and we should focus any to solve and handle any CT saturation to confirm our differential protection is working like nice and working in a proper shape. At least we are securing stability of our protection scheme. And here's some curves which confirm in case if we have some saturation, there is some like differential. Usually, if we are normal wise, our difference should be around 0, except if there is some saturation value, we may face some differential component which lead to mal operation and false tripping of our differential protection. So let's focus now on which factor we should take care about, and those factors are affecting our differential protection on transformer. We said that current transformer error, if there is any error in the current transformer, such error may be in the ratio, may be in the phase shift, may be on the alignment. So any type of error existing on the current transformer will lead to false operation. And that's why any transformation error associated by CT should be identical at the end for both sides, at least to achieve some healthy operation during the fault condition. So we should take care of any transformation error may associated and exist in the current transformer. And also same concept, we have if there is some ratio error in the current transformer, it would lead to also to error on the operation of the differential protection. If there is error in the phasor at the end between I2, which is secondary current, we have reflected secondary current, we have a certain phase shift. Such phase shift leading to error component here. So the component has a value and a shift. If there is error in the value, also if there is error on the phase angle, both will creating error component. So the error component can result it based on the value or magnitude of the current or the phase angle or the phase shift between current. So at the end, if there is error in the ratio, either value or phase shift, it would lead to the error. And again here, the phase angle error. And usually we have three-phase primary side and we have three-phase secondary side. Especially we are using or applying our protection on a three-phase transformer. Such a three-phase connection, either star delta or delta delta or delta star. So based on the connection, based on the winding connection between both sides, either star delta or delta star or star star, and so maybe some phase angle shift or some phase angle difference between both sides. So also we should take care that the phase angle error between both sides would affect the operation of differential relay. So the differential relay would be affected by the connection of the power transformer, either it's star delta, delta star, and so on. So based on the three phase, at the end we have three-phase system. Phase A, phase B, phase C. We have some line values and we have phase current and line current. So usually there will be some phases between primary side current and the secondary side current. And the normal formula between phase current and the line current, that the line current is equal phase current multiplied by square root of 3 by turns ratio, and there will be an angle shift of 30 based on the three-phase steady-state operation. That is how we can relate primary and the secondary phasors on steady-state operation. Those are some standard. At the end, we need some standard for IEEE to act on protection. And those are how to describe your transformer based its small unit, medium unit, and large unit. And at the end, we have a certain IEEE standard here. That is the standard of IEEE, which we should focus on to work on the protection and the coordination for any industrial and commercial power system. Practical cases, we have those names for, at the end, we have 52. 52 is the overcurrent relay protection. And the 87, if we count on a practical market, the device with a number of 87 are referring to the differential relay. So we have 87, like 52 always referring to overcurrent relay, and 87 always referring to a differential relay. So we have differential relay 87, and it would act again based on the difference of the current between the phases. We can put some differential protection on the line and some differential protection on the ground. And from here, 87 would act to protect the differential current and to limiting the duration and the risk of any difference current may appear between phases or between both side primary and secondary within the protected area. So we have the differential protection devices which act on the difference here. Again, it's the same one. We can incorporate the overcurrent protection with other type of protection. So the differential protection can collaborate as a second layer of protection with the overcurrent protection. They can communicate with each other. We are keeping overcurrent protection like 52, and also we are putting another layer of protection, which is 87, to act for differential protection. And here again, we have a certain CT1, and we have a certain CT2, and we have shaded area here. If you see, there is a gray area here, which I am trying to put a border around. Those gray area between CT1 and CT2 are the protected check zone. So we are checking and protecting such a zone to act like a differential protection for such zone. So the protected zone is those shaded, and now I am putting some red border around. Those are the area which you are protecting. Now we are finished two of our main topics or titles: transformer as a concept, differential protection as a concept. Now we will jump to how to apply some practice. And I believe, as it is a first time, I would consider and guess and suppose it is the first time we are going for the Dick Silent power system solution, PowerFactory. We will give some tips and the guidance and the foundation how you can build your modeling and the application on Dick Silent. At the end, Dick Silent, the software, which is mainly from PowerFactory, it has some other divisions for stationware and monitoring ware. Dick Silent itself, it's like three cores, one for stationware, one for monitoring, but the major core is a PowerFactory, where we can build the power system, where we can analyze our power system, doing analysis for power system, either generation, transmission, distribution, industrial level. So Dick Silent can be considered like an integrated power system analysis tool for all level generation, transmission, distribution, and industrial. Those are many analysis studies can be done using Dick Silent. We can do lift flow, cable sizing, dynamic simulation, EMT, electromagnetic simulation, eigenvalue analysis, harmonic analysis, reliability, stability, contingency. So it is like optimal power flow, economic dispatch, and so on. So SCADA also. So it's like integrated hub for any power system analysis and study. And let's now go for Dick Silent, how to practice. So let's start for some foundation and the practice to link our topic, which transformer and differential protection and the protection schemes by PowerFactory. At the end, we should be familiar. After installing the software, we should have an access and start our PowerFactory. At the end, we will find like application example. We will find IEEE example, 9 bus, 14 bus, 39 bus. We will have transmission, we will have protection, we will have renewable, and from there, we can apply some load flow and some protection scheme. We have a certain mean value here. From here, we can open, save, create a project. We can edit, insert component. We can apply some calculation, either it is load flow or protection, and we can create our case study. So for example, if we are moving back and try to build and to run a case study for the 14 bus system, IEEE system, we can find a system here which we can modify. We can apply certain protection scheme on, but at the end, that is like a workspace of PowerFactory IEEE 14 bus. And from there, we can build our differential relay. At the end, our differential relay, as we was telling, It is like current transformer on the primary, current transformer on secondary. We have primary side, secondary side, and we have here the sense and process case. So either we can use the ready-made. There is a library which includes protection and differential protection. We can use those examples, or we can build our customized protection, differential protection scheme. So we can find some example for load flow, for low voltage network distribution voltage. And from here also, we can build here, we will find here the case study. So we have case study for load flow, we have case study for dynamic or for cable, and from there we can insert some transformer if we need to focus also on the transformer segment. Then we need to confirm how to add a new component. So for example, if we are using such 14 IEEE bus and we need to add a new component, like a new transformer or a new relay, how to use, we will find here on left-hand side of the program itself, we will find two tabs, one for the project, and the other main one is drawing tool. From there, we can draw, we can edit, we can change, modify setting, we can add a component. So first of all, you will find some freezing mode, and you should start to unfreeze such one using view. So from view menu, drop menu, from view drop menu, we will select graphical freeze mode, and from there, you will find all components are now active. So you can insert any component. You can insert transformer, you can insert generator, you can insert a filter or shunt element. Whatever component you need to add, you can add buses, for example. After you unfreezing such drawing tool, you can drag and drop some buses or generator or cable and so on. So it's like a big, so for example, if you need to add transformer, you will find a family of component called transformer, and where you can add such transformer. After you drag and drop such a transformer by double click on such a symbol, I would say you are able to confirm all settings for such a transformer. You are confirming, you can confirm low voltage side and high voltage side. You can confirm megavolt ampere. You can doing some setting for load flow setting, short circuit setting, and so on. So you are able to drag and drop to add a transformer, and from there you can adjust and modify the setting on your transformer, either using short circuit value to confirm which simulation you will add. So you are adding data for load flow, you adding data for short circuit and for protection, and then based on the study, you will use those data will be applied on. How to apply a certain study, how you apply certain analysis. Here from such, we have a calculation and we have output view drop menu. You can add short circuit, you add load flow, you can add and do contingency analysis. You can make some simulation. We have a bunch of study and analysis, like integrated ones, we can apply after building our circuit or grid. After adding some component, we will apply those bunch of study and analysis, either load flow, and we have, for example, a certain protection function. Here we have on PowerFactory last version, which we have, which 2024, the one which we applied on our course, we will have like advanced protection example, which include differential protection example. We can here from such button here, we can click to add our advanced protection here. And we have industrial, by the way, we have also a ready-made industrial example with a protection where we can build here our system. We have a grid, we have some buses, we have transformer, and we have certain loads. And from there, we can activate our protection analysis. If we activating our protection analysis by right click, if you are doing right click on such protection tab here on case study and you activate, you will find that there are many protection devices will be activated. And from there, we can open like such data, which relay model data to network model. And from there, you will find in your system, you can apply either different model for the relay or apply the differential protection, which our focus for today. Our focus is differential relay, and you will find in the library of the relay model for the Dixieland, you will find many different types of overcurrent relay and some types for the differential relay. And if you see here also, all of those differential relay are remarked as 87 as we confirm it in our presentation. This is how to add differential relay to your network. Also still just to give like an overview and the framework about PowerFactory Dixieland for 2024. Also, it has some renewable cases and example like for wind. Also from wind, you can apply short circuit calculation and the protection coordination. You can add at the end, that's one of those examples. We have a generator, we have a transformer, and we have a grid, and two overhead transmission line, and also some zoom for such a one. So such a relay, how to add a relay now? How to add a relay for your system? We have a relay, we have, we can create a relay, we can create potential transformer and the current transformer. And we can create some case study, and those are the transformer protection. And how to create it at the end, those components, if you remember just some minutes back, we were referring to the drawing tool. On the drawing tool, there is a search bar. So if you search for relay, you will find a relay model, you will find a current transformer, you will find a voltage transformer. So you can add a generator and add a relay as a primary side and a relay as a secondary side. At least you can apply any type of protection using the relay, current transformer, voltage transformer if needed for your transformer. That's like, I hope our session today give us like a good knowledge or about transformer session, about topic, about the differential, how to add some principle and the foundation about Dixieland. I know it may be quick based on our agenda and the timeline today, but most welcome to have any question and consultation. And I hope see you soon on the course itself, because more and detailed information and analysis and the knowledge will be included in. I hope it is in the time. Thank you everybody for now, and I will leave our coordinator to finish the session today.
Thank you, Mr. Ahmed. Now I will present my screen.
Sure.
Okay. We really appreciate the masterclass that you just done. Remember to the participants that your questions will be attended in a personalized way through your email addresses that has been registered. Now I leave with you our commercial executive, Lisbeth Ore, who has very valuable information to share with us.
Okay, thank you, Fabricio. Hi, dear participants. I'm Lisbeth. It's a pleasure to be with you. Well, this masterclass is just a preview of the protection of electrical power system specialization program, which begins on November 23. Okay, and now we want you to take your career EIRL forever, so we invite you to join our next forum. For today's participation, you have a special discount of 10% by sending us the code MS2455. With our specialization, you will have three great benefits. First, our teaching methodology is focused on practice. Also, you will have access to our free courses and master classes on the platform. And of course, you will have 1 month to make your consultation after finishing the program. Okay, remember that the course will grant you a double international certification. One of them in the name of Inel and the other in the name of the Institute of Electrical and Electronic Engineering. For more information about this program, scan the QR and I will contact you to help you sort out your vacancy. Great. And there's also an upcoming masterclass about real application case of transmission line protection in PowerFactory. That is why we invite you to pay attention to our social networks so that you cannot miss it. That will be all for me. Now I'll leave you with Fabricio for today's certification.
Thank you for your information, Lisbeth. So, dear participants, as I say, we have a reward for your effort to be in this masterclass. Ines will give you a certificate for your active participation. To get it, you should follow the next steps. First, enter the form or scan the QR that is showing the screen. This will open a Google form that you should complete with your information. This certificate will be sent in by your email address. Remember that email is compromised with your learning. Congratulations for your participation. The Inel family wish you a good day. I will leave for a few minutes this QR if you have consultations about the masterclass or any doubt about the program. Thank you very much again of all you participants. That was a pleasure. Have a good day.